Imagine yourself alone on the vast southern ocean, the wind slicing across a world of white and steel blue water. Now picture leaning over the edge and peering into the depths below. You might expect to see little more than drifting plankton or the occasional silver flicker of a small fish. But instead, in that dim, frigid realm, something altogether stranger awaits. Creatures that resemble spiders stride across the seabed on legs longer than a man is tall. Jellyfish trail veils of tentacles that stretch farther than the length of a blue whale. Even the most ordinary-looking fish seems swollen beyond reason, as though the cold itself had inflated them into giants. This is no fantasy. It is one of evolution's most astonishing experiments, a phenomenon known as polar gigantism. Hidden in the coldest oceans on Earth, far from human sight, life has not withered in the freeze, it has grown. In a place where temperatures hover around the freezing point of seawater, where food can be scarce and sunlight fleeting, logic might suggest that survival favors the small and efficient. And yet, here, the opposite has occurred. The cold has rewritten the rules. To understand how, we must descend into those dark Antarctic waters and meet one of their most formidable inhabitants, the colossal squid. For many, the colossal squid is a creature of myth, often confused with its equally famous cousin, the giant squid of the deep sea. But the colossal squid is not merely a resident of the abyss. It is, above all, a child of the polar ocean. It dwells in waters that linger at or even below 0 degrees Celsius, temperatures made possible by the salt that prevents the sea from turning to solid ice. Such cold would seem inhospitable to life, yet it is precisely this chill that has shaped the extraordinary form. The colossal squid belongs to a lineage known as the glass squids, a family of delicate, translucent animals whose bodies are almost invisible in open water. But in Antarctica, transparency offered little advantage. In its place, evolution favored something different. The colossal squid abandoned its fragile, see-through form and developed thick, muscular flesh, insulation against the relentless cold. Its skin took on a deep reddish hue, absorbing what little light penetrates those depths, even the faint glimmers of bioluminescent prey. It does not shimmer, it does not betray its presence, it advances unseen. And at such immense size, weighing more than half a ton, it has few enemies beyond the formidable sperm whale. Its strategy is not escape, but ambush. But why grow so large at all? The answer lies not in abundance of food, but in the chemistry of cold water itself. Frigid seas hold far more dissolved oxygen than warm tropical waters. Oxygen is the currency of life. Every cell depends upon it. In warmer oceans, the supply can limit how large a body can become. There simply is not enough oxygen to sustain enormous tissues. In Antarctic waters, that limitation eases. Oxygen is plentiful, and when combined with the slowing effect of cold temperatures on metabolism, the rate at which an organism burns energy, a remarkable opportunity arises. Large bodies, which in warm climates would be costly to maintain, become surprisingly efficient. They consume energy slowly. They endure. Over millions of years, this combination, abundant oxygen and reduced metabolic demand, removed the ceiling on size. Glass squids, once modest in form, expanded into colossi. In the case of the colossal squid, another influence deepened the effect.
It inhabits not only polar waters, but great depths as well, where additional evolutionary pressures can also favor large size. The result is a rare convergence, both polar and deep-sea gigantism working in tandem, producing the heaviest invertebrate known to science. Yet the squid is only one chapter in this frozen epic. On a coral reef in warmer seas, a sea spider is a modest creature, scarcely larger than a coin. Delicate, almost dainty, it creeps unnoticed among corals. But in Antarctica, its relative is transformed. There, sea spiders can span more than half a meter across. Their legs stretch outward like the spokes of some alien machine.
Unlike true spiders, these marine arthropods breathe not through lungs, but across the surfaces of their bodies, especially their legs. In oxygen-rich polar waters, those elongated limbs become extraordinary conduits. With more oxygen available, their bodies can expand, and expand they do. They move slowly over the seabed, towering above sponges and starfish, their long proboscises piercing soft prey and drawing out nourishment. And the prey themselves are no less remarkable. Consider the Antarctic starfish. In tropical seas, most starfish display the familiar 5 arms. Here, some species bear dozens, 20, 30, even 50 arms radiating from a single center. They are larger, longer-lived, and often more formidable than their warm-water cousins. Some endure for over 40 years, their lives unfolding at a pace dictated by the cold. In this environment, survival is measured not in speed, but in patience. Even the drifting jellyfish have been shaped by the freeze. The lion's mane jellyfish, whose tentacles can extend for astonishing distances, claims the title of the longest animal on Earth. In warmer waters, its relatives remain comparatively modest, but in polar seas, the same forces, oxygen abundance and slow metabolism, allow its trailing threads to reach extraordinary lengths, transforming it into a ghostly titan of the currents. And it is not only the large and dramatic that are affected. Even plankton, the microscopic foundation of marine food webs, have their giants. Antarctic copepods, relatives of species so small they are nearly invisible to the naked eye, grow to sizes many times heavier than their tropical counterparts. In the world of plankton, such growth is monumental. Yet evolution in the polar oceans does not follow a single script. While most cold-blooded creatures have grown larger, a few have taken the opposite path. Certain Antarctic fish species are smaller than their relatives elsewhere. In a land where food can be seasonal and unpredictable, remaining small can be advantageous. A smaller body matures more quickly, reproduces sooner, and survives lean times more readily. This phenomenon, known as polar dwarfism, is rarer, but it reminds us that evolution is never simplistic. It is a negotiation with circumstance. There is another, subtler effect of the cold. In these waters, life moves at an unhurried tempo. Chemical reactions slow. Growth is gradual. Reproduction may take years, even decades. Some Antarctic invertebrates produce a single generation in a span that, in warmer seas, would see many cycles completed. As a result, evolution itself proceeds more slowly. Many Antarctic species appear almost unchanged from ancestors that lived millions of years ago. They are, in a sense, living archives, organisms shaped for a world that, until recently, remained astonishingly stable. The temperature scarcely fluctuated, the seasons, though extreme in light and darkness, followed predictable rhythms. Predators were few, competition steady but not chaotic.
In such constancy, gigantism flourished. But therein lies the vulnerability. Creatures designed for stability struggle when the rules shift. As global temperatures rise, polar waters warm, even slightly, and warmer water holds less oxygen. Metabolisms begin to accelerate. The very factors that once enabled vast size begin to reverse. For giants built upon the abundance of oxygen and the efficiency of cold, this change is perilous. A body that once conserved energy now demands too much. Studies already suggest that in some regions, maximum sizes of Antarctic sea spiders are diminishing as waters warm. The implications ripple outward. If trends continue, even the mighty colossal squid may find its reign curtailed, not by predator, but by physics.
These creatures, so strange and imposing, pose no threat to humanity. No recorded death has ever been attributed to a colossal squid. They are not monsters of malice, but marvels of adaptation, living testaments to what life can achieve under the most unlikely of conditions. In the end, the lesson of the polar oceans is both wondrous and sobering. Freeze the sea, and life does not merely endure, it transforms. It stretches the limits of form and scale, crafting giants from humble ancestors. But warm that same sea, and the spell begins to unravel. Beneath the Antarctic ice lies a realm where evolution once ran in slow, majestic motion, sculpting beings of improbable size and quiet resilience. Whether those giants will endure the changes now unfolding is a question still being written in the currents of a warming world. For now they remain, vast, patient, and almost otherworldly, drifting in the cold, dark waters at the edge of our planet. Reminders that nature, given the right conditions, can make the smallest of things grow astonishing.